Hello class, today we're going to talk about midpoints and medians in triangles. So first we're going to deal with midpoints. The definition of a midpoint is a point that divides a line segment into two equal segments. So here I have a triangle ABC. If I were to find the first midpoint in the line segment AB, I'm going to have a point called D. Now, according to the definition, the distance between A and D is the same as the distance between D and B, because the midpoint intersects the line segment AB into two equal segments. And then, if I were to find the midpoint between B and C, that point E should also divide the segment BC into two equal line segments. And then, if I were to find the last midpoint between A and C, call this F, they should also intersect such that A and F is the same distance between F and C. So let's explore some properties about midpoints and triangles. So here I have a triangle ABC in GeoGebra. I'm going to use the program to help me calculate the midpoints. So let's have the program calculate the midpoint between A and B. There's my D. And then again between B and C. And there's E. So let's verify the property of a midpoint by calculating the distance between A and D. That's 3.81, and then from D and B. That's 3.81 as well. So therefore the property is correct, that the midpoint D does intersect the line segment AB into two equal line segments. And let's verify that also with E. So B and E and C. Again, the two distances are the same. So E does intersect BC into two equal segments. So why are midpoints important? Well, there are some properties about these midpoints in a triangle which we're going to explore. Now, if I were to create a line segment between D and E, do you notice that the line segment D and E is parallel to the third side, which I haven't found the midpoint yet? So D and E is actually parallel to A and C, meaning these two lines will never intersect with each other if you continue them through. Also, let's look what happens when I calculate distances. That distance is 4.5, and A and C is 9. This is always the case, such that the midpoint line segment is going to be half the distance of the third side of the triangle, which we haven't calculated. So if you ever see a triangle with a midpoint line and the third side, you always know that that distance is always half of the third side distance. Okay, any more properties? Well, do you remember how to calculate the height of a triangle? You need to find the top vertex, which is vertices, which is B, and calculate the perpendicular. Oops, excuse me, that was not correct. And calculate the perpendicular distance to the line segment AC. Apparently there we go. So there we can calculate the height of this triangle through B to the line segment AC, because this angle here is perpendicular. So the distance, if I create points now, where this line segment intersects the AC, that distance to B is the height of the triangle. So what does this deal with midpoints? Well, if I were to take this line, this height line segment, and put a point where it intersects with the midpoint line segment DE, and then calculate the distance, do you see that this distance BG, and then from G to F, is actually the same? And this property is the same for all triangles, whereby the height of the triangle intersects the midpoint line is always going to intersect it into two equal parts. Alright, so you're going to explore these properties through the activity today. So let's bring all the things we talked about into an organized chart. So here are the key characteristics of midpoints in triangles. So the first key characteristic is the fact that the midpoint intersects each side of a triangle into two equal line segments. As you can see here in this diagram, the triangle ABC, the midpoint D intersects the side AB into two equal line segments. The second key characteristic is where a line segment joining the midpoints of two sides of a triangle is parallel to the third side. So as we saw earlier, if I found the midpoint between A and B, which is D, and midpoint between B and C, which is E, and then join those two midpoints together, this line segment DE is parallel to the line segment AC, which is the third side, which we haven't calculated the midpoint yet. Also, with this line segment is the fact that this distance, DE, is also half the distance between A and C, as we saw 9 versus 4.5. And the third characteristics of midpoints in triangle is the fact that the height of a triangle formed by joining the midpoints of two sides of a triangle is half the height of the original triangle. So this height here, BG, is only half the distance of the original height, BF, because it intersected the midpoint line segment, DE, and that point G is halfway between B and F. So this height is half the distance from B and F, or the fact that these two line segments are the same. So hopefully you can use these key characteristics of midpoints in triangles to help you figure out geometrical measurements when you see midpoints in triangles. The next video will talk about medians in triangles, so look out for that one.